Hey everyone, welcome back to the channel. So today I will be solving an interesting backtracking problem, and the question number is 1718, and the question is construct the lexicographically largest valid sequence. So it's a medium difficulty problem, and I think it requires but it requires a strong problem solving skills, or also recursion knowledge, because if you ever struggle with like backtracking concept, then I think this is the best or perfect example problem to sharpen your skills. So let's first understand what is lexicographically, then I will move to the question explanation. So lexicographically, in simple terms, you can understand it by definition, like it is like a dictionary order where numbers or words are arranged based on their left to right sequence. Just like in dictionary we have examples like apple, then banana, then cherry, and then so on. So the sequence arranged in left to right manners. For like numbers, it means comparing digits from left to right and prioritizing larger numbers first when possible. So in lexicographically, basically we have to prioritize the larger number first and then so on. Like for example, numbers given are 3 1 2 3 2. It is larger than 2 3 2 1 3 because 3, the number, this is 3, comes before 2, right? Obviously 3 is larger than 2. And the words apple, it comes before banana because a comes before v. Common sense. Okay, now how it applies to our problem? Like we have to place large number first. In question it's given, wait, I will show you. In the question you have given, we have to return the lexicographically largest sequence. Okay, got it. So here it is written how it applies to our problem. We have to place large number first to get biggest lexicographical sequence, and if two valid sequence exist, the one with first larger number wins. So understand it by seeing example. So how do you say this is a like lexicographical number? Like in from this example, which is larger? 5 3 1 4 3 5 2 4 2, and these numbers. So obviously answer first one, because 5 is greater than 3 at first position, right? And this logic helps in constructing largest possible valid sequence. Now come to the problem explanation. Okay, so first let's understand it by breaking the problem in simple words. So let's understand. So we have given an integer n, and we need to construct a sequence that satisfies these following rules. Okay, we have to satisfy these following rules. Now the first rule is saying the number 1, integer 1, appears once in the sequence. So 1 should appear once in the sequence. Okay, got it. Now second point is saying each number or integer between 2 and n appears twice in the sequence. Okay, so from among 2 and n number, the number should occur twice in the sequence. And the third point is saying is that for every integer I between 2 and n, the distance between two occurrence of I is exactly I. So what does it mean? uh, Also the hint is given. So the distance between two numbers on sequence a of I and a of j is absolute difference of their indices modulus j minus I. Let's understand this by seeing example. For example, if 2 appears at position x and y, then we can say in mod of x minus y it will be equal to 2. Okay, we need to return lexicographically larger sequence, means we should place bigger number first. As I discussed, earlier, lexicographically means we have to follow the dictionary rule. From left to right, the bigger number should place first, then so on. Okay. Uh, and from this example, you can also understand the distance means gap between two indexes. Like for example, we have given input n is equal to 3. Okay. We have given input n is equal to 3 and output we get as 3 1 2 3 2. Okay, let's see the explanation. 3 appears at index 0. Okay, and also 3 appears at index 3 0 1 2 and at 3. Okay, now the distance between these two numbers 3 and 0, obviously that will equal to 3, and 2 appears at index 2 0 1 2, and 4 appears 3 1 2 3 2, and 2 appears at index 4 also. Okay, at index 2 and index 4, so the distance between 4 and 2 is 2, and 1 appears once at index 1 only. So you can see the distance between two number is 3, as 3 minus 0 and 4 minus 2, the basic maths here used. Okay, now uh, for beginners, just for naive, how you will think like which DSA will use here, which approach I should use. Okay, it's medium level problem, so think carefully. Now first see how to think about the solution by seeing the question. So we need to construct the array by placing numbers in valid way while ensuring the biggest number comes first. It is written in the question only. To get lexicographically largest sequence, right? And each number is I is placed twice with these all points are written by question itself. Now the DSA concept used will backtracking concept, because we need to try placing numbers one by one, and if placement is wrong then we have to go undo means backtrack and try another approach. So we have to use backtracking concept here, and recursion, because we recursively attempt to build the sequence by filling empty position. Now let's understand this by seeing question. So the from the question given, we have to analyze which concept or DSA we have to use. Like we have to find all possible sequences. Okay, so we need to trying multiple possibilities. That means we need to use backtracking. Okay, I couldn't write this when is required for this. Okay, rub this to find, basically to find all possible sequences. We need to use backtracking, and to choose numbers undo and retry we need to explore different paths. That means we need recursion, and to need optimal arrangement backtracking finds valid sequences. And so let's try this by doing their code. Let's start the code. Okay, we just need to increase the font size. Let me first increase the font size. It should be 18 pixel. Okay, got it. Yeah, it's visible now. So this is the default code. Now what we are doing here is that we define our function, right? Construct distanced sequence. Now and size equal to multiply and minus 1. Also I should write comment so that we can understand it. Total positions in the sequence, And what I will do is that, okay, now int result equal new int size. It will initialize array with zeros, and boolean used equal new boolean n plus 1, right? This statement use, wait a minute, this statement use to check if a number is used or not. Now what's happening there is size equal 2 times n minus 1. Okay, so basically 2 times n minus 1 is the total length of the sequence stored in variable size, and result, this is where we store the final sequence, and use is where this boolean array keeps track of numbers we have already placed. Now step 3 will be calling the backtracking function. So let's start. Let's call the backtrack function. So backtrack result used 0, n, it will return result. Okay, now why do we use backtracking? Because I already said we recursively place numbers from n to 1, so we have to try different placements, and if placement doesn't work, then we have to undo it, means backtrack. So we have to try another way. Now step 4, what I will do is implement the backtrack function. So let's try private boolean backtrack parameters result boolean used integer index int n. Okay, yeah, so what is index here is this is the actually current position we are trying to fill in result. Okay, and if index equal, now first write the code. If index equal if index equal result dot length, then it will return true, right? And if result of index not equal to 0, then it will return backtrack result used index plus 1, n. So what's happening there is if current position is already filled, then we simply move to next index, and if not, then trying to place numbers means backtracking we have to do. Now applying for loop for int num equal n, num greater than equal 1, and num minus minus, sorry, num minus minus. So this is basically I used to place the larger number n, and place the larger number first, Okay. Now we start from larger number and go down one as from question instruction. We need to get lexicographically largest order. That's why we have to follow that sequence. Now step 7 is to check if number is already used or not. So for this we need to write if used num, then continue means escape if already placed. Otherwise, if we have already placed num in the sequence, we have to like skip it, and if not, then step 8 will be handling one separately. Okay, so if num equal 1, then it will give result index equal 1 and use num equal true, and if backtrack result used comma index plus 1 and then it will return true. Okay, it's little bit tough, but I guess it will clear your all backtracking or recursion concept. So just try once. First go through all those points what the question said and applying to code. So yeah, it will return true, and in result of index it will give 0, use num equal false. Okay. Now since one should appears once, it's already given an instruction that integer 1 should occurs once in the sequence, and then we need to move next position using recursion, and if placing 1 doesn't lead to solution, then we need to undo it, means backtracking. Now step 9 will be placing bigger numbers at 2 positions. So else int second index equal index plus num if second index, wait a moment, second index less than result dot length, and result second index equal 0, then result of index equal result of second index equal num. Okay, otherwise used num will equal true, and if not, then backtrack result used index plus 1 and then it return true. Okay, so basically it will undo the placement, it will undo the placement. Okay, and result index equal result second index equals 0 used num that is equal to false, right? Now okay, so if num will greater than 1, then we must place at it 2 position, first at index and second at index plus num, ensuring like correct distance. So if placement is valid, then we proceed recursively. Now if we reach a dead end, then we have to like remove the number, backtrack and try something else. Now step 10 should be like we have to return false if no valid placement. So yeah, return false, return false. Okay, okay, so let's run the code first. Error rest end off while parsing. I think one bracket, so there. Wait, I need to check first. Okay, yeah. Let's again run the code. I think it should be run now. And 29 number, it's showing error. Okay, result dot length and result of second index spelling mistake. Okay. Okay, index num variable index. Okay. No more mistakes now. Okay, so finally submit the code. Let's see. Yeah, it beats 100%. So, what are you thinking? Like, what could be the so the time complexity of this question would be to big O of 2 की power n, and the space complexity will big O of n. Why big O of 2 की power n? We can see from questions given instructions or points. Like we have already given binary choices at each step, so we can understand from this point, like for each number n to 1, we either place it at valid position, or if not, then skip and try other. So we have basically two decision, so that's why we have double possibilities, and the time complexity will be big O of 2 की power n. Also we can take various examples whose time complexity is 2 की power n. Like you can see from Sudoku problems or problems like word break. Yeah, problems like word break, palindrome or partitioning involve problems. So yeah, that's why the time complexity is 2 की power n. Whenever you see the two conditions like include, exclude, split, not split, number of possibilities, when there are doubles, then you have to remember the time complexity will be big O of 2 की power n. I hope so you will understand now the questions and their time complexity all in details. I have explained well. So yeah, thank you for watching.